Okay, so hello to our little talk. We have like 15 minutes, so let's speed that a bit up. Who are we? Basically, I'm Birk, and this is Dennis, and we got paid to look at computers. So what is this talk all about? Basically, we have like a little history of appliance we look at every year and so on. And you can basically see a lot of stuff we found in the back, and some of you maybe have it in your network. So we figured out, well, it's 2019, let's go for another one. And yes, we found some stuff. So we're talking about that appliance. It's called Formetrics Data Security Platform. It's now from Thales. Let's put a short history there. So 2014, they actually won an award for the best encryption solution. I will get into the encryption part and the crypto appliance in a short amount of time. They got bought by Tails for like $400 million. So you can imagine there's like quite some money in that business. And they actually won a cybersecurity award, which makes them like perfect, right? And in the enterprise, they are kind of known as the holy grail of cloud encryption. 2019, let's see. So there's features. We have not so much time, so we will go mainly into the transparent encryption part. But it's like an enterprise appliance that can do basically everything for you because it has like an HSM, a key management, all that stuff in the appliance itself, and it manages everything. So just to get a bit into an architecture of the transparent encryption, what the idea is, you put some data into the cloud or on-premise, on file systems, and this machine or this appliance is actually in the middle, and it holds all your keys, basically all your value. And whenever you want to request data, you actually get it from it. So the appliance is encrypting and decrypting it at the same time. So basically for the cloud, you only have encrypted data there. And if you request it, you get the decrypted data. So it's quite a thing because especially like in Germany, people don't trust the cloud at all. So you can just drop encrypted data somewhere you want to. You can see like, it's safe there. And you can basically store it wherever you want. So yeah, we got that box, and this is like the first part where Dennis takes over.
Yeah, so our first objective basically was to get a shell on this thing because per design, this does not allow to get you like a bash or something. You only have this command line interface. So if you plug in like a serial interface or if you connect it via SSH, you will drop into this admin CLI shell, and there you have several categories of commands you can run to configure this thing and also to maintain it. And yeah, basically most of the commands will just be wrappers for your basic Linux tools. And yeah, it's pretty restricted. So basically, you are not allowed to put in any special characters. So your typical command escape things will not work. And I think let's just directly go into the demo to see how this shell looks like and how we did manage to break out.
Yeah, we got dropped. Okay. That's kind of how it looks like, yeah.
So this is shell. Basically, a tab completion. There's several like subcommand categories, and the thing we found was in the network category. So let's just go in there. And as you can see, there's probably just wrappers for Linux commands. And the interesting thing we found was like this one, this IP diag, which in the usage says just give me an IP command. So let's just do that. Maybe you know that one. And this actually looks like it's just directly calling the command of the Linux IP tool. So what happens if we try to concatenate another command? Let's just do it like this. Okay, so this will not work because there's a special character in this, but maybe some of you know that the IP command is actually pretty powerful and you can do a lot of it. There's network namespaces, for example. So you have this network namespace subcommand of IP. You can add another network namespace. Let's do Kawaiicon. Cool. Okay, that worked. We now have a Kawaiicon network namespace. And what you can also do is just execute other commands inside network namespaces. So let's do ID again. And oh, we have a root shell. That's quite nice. So basically, that was the first vulnerability we found. We have a command injection in the admin CLI, and this also got us onto the system to then do further research. And so let's look at the attack surface we have on this device. So basically, there are several network-facing services. We have 2 binary services running on this. They're marked in red. And those are pretty interesting because the firewall actually lets you access those. And so I wanted to take a closer look at them. Also because the hardening of the system is pretty interesting, because basically you don't have ASLR globally. This is 2019, by the way. And so let's look at this first one, this RA server. I think it stands for Remote Administration Server or something. The binary itself is not compiled with PE, so you actually don't have ASLR with or without a global setting. You don't have stack canaries, and the funny thing is you also have an executable stack. What the fuck? Okay, let's how did we go on to this? Because there were actually several other services there, and we didn't have much time, so we decided let's, for the binary services, just write a fuzzer, let it run in the background, and then look at all the other stuff. And the problem with this is we basically have like a black box approach here because we don't have source code, and so your usual fuzzer like AFL would not work. And you can also do like dump fuzzing with tools like Redamza. You can generate different payloads and just throw them at the service and see if it crashes. But without like a coverage feedback, this is not very efficient. And so we wanted to try something else here. So what the idea was is basically we wanted to use Frida. Maybe some of you know Frida. It's a binary instrumentation tool. And to just get the coverage out of this running binary. And we wanted to do that directly on the appliance. So Frida has a module called Stalker, which does exactly what we wanted it to do, because with this you can basically trace the program as it runs and get information which basic blocks were executed. And so the basic architecture looked like this. We wrote our Python fuzzer. We used Redamza as like the mutation engine to mutate our corpus and throw the payloads at the target process over the network. And then we did a little bit of reverse engineering of the target process to find like the interesting parts of this program. So for example, the parsing function which parses the packets that are received over the network. Oftentimes you can do that pretty quick because you just throw it into IDA and you see where does it do a lot of networking stuff, and then there's somewhere a function that will parse your input. And so we like combined this approach to do a little bit of reverse engineering, find this parsing function, then use Frida to hook this parser function to attach the Stalker module so that we only get coverage for this function and not for everything else, so that it's a bit quicker and doesn't take that long. And then we have this coverage information, and we can use it to do like a genetic fuzzing approach. There's also another interesting thing we could do with Frida. We could just do in-process fuzzing. So sometimes if your parser function does not really handle global state, but just takes like the network package as a buffer and then parses it, then you can just directly invoke it from Frida, and you don't have to care anything else what the process does. And so depending on your binary, both of this will work, and some of it will be faster or better. So the fuzzer is still work in progress, but released it just today. So if you follow us on Twitter, or we will show the Twitter handles later, you will see the link to GitHub. It's not ready yet, but some of the features already work, and maybe you can use it already. But yeah, we will continue to work on this and maybe add some new features and make it a bit better, and also add documentation. Okay, so actually we didn't find much with that, but we found a denial of service. So one of the first things the fuzzer found was that you can put this RA server with a certain payload into an enters loop, and which generates a lot of CPU usage. And so this was at least one vulnerability we found, but yeah, we plan to use the fuzzer also on other projects, so it definitely wasn't wasted time. Okay, so I'll give it back to Birk.
So let's go further. We now had access to the system, like we showed before, like with the CLI breakout. Let's look for some more interesting parts of the system. So the first thing we really found was like basically there's like a service running that is triggering a script that's called outed user login. So don't get scared from all the code up there. This is basically only a bash script, and what it does is like parsing SSH logs. So what could go wrong with parsing SSH logs, right? Well, if there's a failed login, they call the audit function up there, and then they're gonna send it to another AES audit whatever function. And just to give you a little hint, this is like the audit function that is called in the end. You have up there like an example message where like the user foobar is logging in. Basically, this is completely attacker controlled. I give you just like 10 seconds. Look at the down of the screen, what's happening there. Well, it's a command injection up there. So we have like an unauthenticated remote code execution with that POC. Basically, you log in with an SSH with a user that escapes the command. And if you look back, it was using 4admin as a user with that, so we still have to do some privilege escalation in the end. But this is basically our whole proof of concept for owning the appliance remotely unauthenticated. So that's also like POC requirement, right? So we have here, we have like an SSH file, and I have a listener here. Let's go. Okay. And we are in the system. So let's escalate to root, right? Remember the first part we talked about, like the CLI that is that we break out of. It's also like a local service that is listening on a port bound to localhost. And basically, if you do exactly the same as we showed you before, you get the privilege escalation on the system, which is quite neat. We also have like a second one. I will show you that one. I just have to copy paste it. I don't want to, maybe I don't have it here. Okay, here we go. That's basically this one. Okay. So what's that gonna do? It opens LCSH, like a local netcat listener, and if we connect to that, so we are currently still 4admin. So if I connect to it on 1337, and I do ID, we are basically root. So yeah, just a little wrap up. There was quite some vulnerabilities we found, and there was like unauthenticated remote code execution, the command injections, several local privilege escalations, rootless feature bypass. We couldn't talk about that because the time is too short, but there were some more features that you can easily bypass that we thought that is relevant for security. We had a denial of service. Well, let's talk a bit about disclosure with such big vendors, right? So I've sent them the report, and they were like, your POC actually displayed a root shell. This is not possible. I kind of tell them, yes, because like we have a breakout, and they were like, ah, okay. So your next guess is like, how many CVEs we got for that? None. Is there any public advisories? Nope. Basically none. So let's say, like, as a conclusion, I guess security vendors still know what they're doing. And please, next time, try harder. And this is basically it. We will be at the venue. Hit us up if you have questions. There's like also the Twitter handle where the fuss is. Thanks.
Thank you.